Suppose there is a mass m that is moving along x-axis under some force f of xt. Now we want to find the position of this particle classically. Once we have a position of this particle classically, that is x of t, we can tell the velocity of the particle, momentum of the particle, and kinetic energy of the particle as well, or any other dynamical variable we can easily find out. But question, how do we go about determining x of t? For this, we will use Newton's second law, that is F equals ma. And for conservative system, F equals minus partial V or partial X, where V is the potential energy. Now the Newton's law becomes m second derivative of position with respect to time. F equals ma, acceleration is nothing but the second derivative of position or displacement. So we simply write m second derivative of x with respect to time equals minus partial v or partial x. Now by using an initial conditions, and that is exactly at t equals 0, we can easily find the position of the particle. This is all about the classical mechanics. Now, how to determine the position of particle at any given time quantum mechanically? For this, first we write wave equation psi of xt of the particle, and we get it by solving the Schrödinger equation, and that is I h cat partial psi over partial t equals minus h cat square over 2m second derivative of psi with respect to x plus v psi, where v is the potential that is facing by the particle, and h cat equals h over 2 pi equals 1.05 into 10 raised to power minus 34 joule second, and I is the square root of minus 1. Now, once we have a suitable boundary conditions, that is a psi of x at 0, then Schrödinger equation determines psi of xt for all future time, just as in classical mechanics, by using the Newton's second law, we can determine the position of the particle for all future time.